Hello, my name is Troy Rosencrants. I am the GIS and Data Manager of the Office of Economic Development at the University of Michigan-Flint. This webinar is to give you an introduction into what GIS is, what goes into GIS, how GIS can be applied to the real world, and then some recent developments that have occurred within GIS. I'd like to first discuss this concept of geographic representation. You take cartography and geography, and together you're allowed to create geographic representation, which is the process of abstracting observations of the real world into either things or events. Things being static objects, so locations of buildings, for example. And events are the state of a process at a particular moment in time, or a particular moment of that process. And so we can look at a spread of disease, for example, with the COVID-19 pandemic. We can look at daily cases and look at a map of that to understand that kind of events of abstracting those observations. And then through cartographic representation, we're able to symbolize these geographic representations through the use of maps. And maps are very, very popular. It's because they're so convenient. They simplify your surroundings so you understand your environment in a very simple and succinct way. And it creates that strong visual impact that allow a lot of people to understand the data. And the function of maps is to communicate that geographic information. There's a variety of different ways to be able to do that through the use of, for example, thematic maps. Thematic maps show one single type of feature. It shows a geographical distribution of that theme, hence the name thematic maps. Many show distribution of concepts that don't actually exist in the real world. So we're looking at maybe median household income, or the population rate, or growth, or decline, or over time, or all those different things don't actually exist in the real world, but you're able to use a thematic map to geographically represent that data. And a lot of thematic maps don't have some sort of geographical context to give you that background information. So for example, these two maps show precipitation in Michigan and also youth population of the Thumb region within Michigan. And both have counties as that background or that backdrop to give you the spatial context to understand what's being shown. Reference maps are the earliest known maps. And these use symbols to locate and identify prominent landmarks or locations of a specific area. Topographic maps, aerial imagery are pretty good examples, as well as road atlases and some others that I'll show you here in a second. But they show natural and cultural features with nothing being more important than the other. It kind of shows everything that's there. Sometimes that can be specific subjects of options, but again, it shows roads, it shows a variety of different aspects of an area, just to give you the relationship or where things are in relation to other things. Reference maps can be used as the next type, these navigation maps. So navigation maps are just maps specifically created to allow you to get from point A to point B. And so topographic maps, nautical charts, aeronautical charts are all examples of these navigation maps. And then the last type of map is persuasive. Now, these could be a reference map or it could be a thematic map, but persuasive maps are the exact same as a persuasive essay. They can be used in advertising, political agendas, religious agendas, by using different types of symbols, different types of simplification, or just in general misleading information. The map makers are able to make sure that you as a map viewer look at a specific area a specific way. And so, for example, the exact same map, just symbolized slightly different using different size, you're able to, or you're looking at it, the same area, maybe a different way when you look at the map on the left versus the map on the right. And then, for example, you might think a location is the center of an entire state, for example, when in reality, you're not really in the middle because of the way roads are. They're not straight lines. You can't get to point A to point B in a straight line in a car. You have to go throughout the road network, which then would be longer than, say, that 50 or 100 miles that this map is trying to show. And then through all these maps, we'd like to think of it as map use, or the process of obtaining useful information to then be able to say, okay, I use this map to solve this problem. And so we have three different concept or parts of map use. First is understanding what is being depicted and how it's being depicted. So that's when you're reading the map. Once you understand what's on the map, then you can do some analysis, take some measurements, look for patterns that you can just visually see. And then once you see those patterns, you can then go beyond the map, which is our map interpretation, which then we can find reasons why that particular pattern might be showing up on the map. And with all this kind of background context of what maps are, how they're used, we get into what GIS and geospatial technology provides for us. And so GIS is just a way of speaking the language of geography. And if you don't know, geography is just the study of Earth's surface as the space within the human population lives. So basically the study of the area that humans live. It's why things are where they are. And then GIS is allowed to speak that, allows us to kind of give geography in action, for example. So GIS can stand for two different things. You have geographic information systems and geographic information science. Systems is kind of doing it or using GIS. The science is what you might learn in a textbook or in a classroom setting. So GIS allows us to visualize different relationships or patterns or trends within spatial data that you might not be able to see in a spreadsheet. So I like to say it's answering the question, what is where when? There's a subject, a place, and time all within that GIS data. GIS started being developed as computers developed. So the first one was created in the 1960s as the Canadian Geographic Information System. And as computers have developed, so has GIS. There's five main components. First, the hardware. So your computer, your laptop, your GPS unit, the satellites themselves that go into GPS. Then there's the software that's on your hardware that allows you to manipulate data or store the data, with data being that third component. Obviously, you need data to be able to visualize. And then you have the methods that you use to then visualize that data or analyze that data or store that data. And then obviously with people, you need people to be able to do or utilize those four other components that make up GIS. So GIS has underlying spatial data. This spatial data can be a variety of different things and it has three main components to it. First, where is it? Is it an XY coordinate? Is it a latitude, longitude? Or is it just as simple as an address, your home street address, or the name of a city, the name of a building? Those can be used as giving spatial context to data. Then what does it look like? Is it a point? Is it a line? Is it a polygon? Some data can be shown as all three separately or just one. And then there's raster data. Raster data is basically just a large grid sheet with equally spaced grid cells that is given one value for each grid cell to represent that area on Earth or on whatever you're mapping. And then what do these data represent? And that's what we have the attributes for, our table data, to understand what is that line? What does it represent? Is it a river? Is it a road? What is the name of that river? What is the name of that road, for example? So all of this spatial data, GIS allows us to answer questions. Any sort of question that you can think of, I like to think that GIS can help, at the very least, answer that question. And this is answered through the use of data analysis or data manipulation, where we overlay layers, we merge layers, reduce proximity analysis, statistical analysis, and basically overlaying all these different layers on top of each other, we can represent the real world and then answer questions we might have. So for example, how far away from a school do students live? We have four different layers in that image. We have the school, we have the road network, we have where the students live, and then also a 2-mile buffer around the school to understand how many students might be walking to school. Do we have sidewalks that are safe to walk to school? And so a school might ask that question and GIS can help answer that. And so the end product for all this analysis, all this GIS data is those maps that I already talked about. It's the most common form of GIS in terms of visually representing your data so that the public can view it and understand it. That's that end product of your question. So it can be a variety of different ways that we already kind of went through. No, not only in 2D or in a flat kind of map, we can also look at it in 3D. If you've ever used Google Earth, that's in 3D. That can help you answer questions. Or just in general, looking at different peaks and valleys of a density map or a heat map. So with GIS, there's also two other types of geospatial technology, and we kind of lump all technology within the geospatial technology of acquiring, analyzing, managing, storing, and visualizing your location-based data. And so we have GIS, which is that computer-based mapping we already talked about. And then we have remote sensing, which is the process of collecting information from far away. So we're looking at from aircraft, airplanes, or drones, or UAVs, or satellites up in space. Those all remotely sense this data off the Earth. And there's a variety of different examples listed there. Then we have GPS, or global positioning systems. It's one form of global navigation satellite systems on Earth or in Earth. We have the space component, which is all the satellites up in space. There's about 26 for the GPS. Then we have the control segment, which is where we make sure that the data that the satellites have and what we're getting as a user are accurate. And how accurate are they, or if there needs to be corrections made, we're able to do that using that control segment. And we have the user segment, which is us using it on our phones, or on a Garmin in your car, or a Garmin that you might take out into the field. There's a variety of different uses: emergency services, understanding where they need to be and how to get there faster. Farming GPS is becoming much more prevalent, so that there can be automation with their processes on their farms. Forensics, navigation, recreation. So when you're hunting or fishing, understanding where you are on Earth is very important with GPS. And then as technology continues to grow and continues to develop, and everything's in the cloud now, GIS is also in the cloud. A lot of things becoming computer-based. Storage, especially for data, is now in the cloud. We have Google Maps, MapQuest, Bing Maps, Apple Maps. Those are all a GIS, and they all are a web GIS. So we've all used it at some point or another. And so here's just some examples. Like I said, data's become more and more stored on the cloud, so everybody's be able to access a lot easier than previously, as well as visualizing and interacting with data, as opposed to just having a static map or a static piece of paper that has a map on it. You're not able to interact with it. Web GIS is allowing us to be able to do that more and more. And also recently, we have a couple different GIS developments. One is where everyone, just the layperson, you, me, anybody is able to actually create geographic information. It's a part of citizen science, where we have such things as mapathons, where there's a large group of people get together and just start inputting data in remote areas across the globe to allow for Red Cross to understand where things are, or if they're doing things maybe out in the middle of nowhere in Africa. This volunteer geographic information is becoming more and more important. And then we have what's known as geolocation. It's a technique of determining where something is in the real world. And you can use your IP address, your Wi-Fi connection, the GPS receiver in your phone or on your laptop. And with all that, now we're able to geotag our media. When you take a photo on your phone, it tags where that automatically where that location is that you took that photo. And then also with geotag tweets or Facebook posts, you can check in places, Instagram, Snapchat, all of those capture location data about where you've been. And then a lot of people end up collecting that. That's what's known as big data, to then analyze it and understand how people are traveling, where people are in the world, what are they talking about, how are they utilizing different areas of your world. So why GIS? GIS can be applied to everything, I like to say. More than 80% of all data has some sort of spatial component to it. And that's very, very important in how GPS can be another tool in your tool belt to then go forward within whatever career you might be in. And there's a variety of different applications, from business and understanding retail, locating new locations, to the spread and occurrence of diseases like in the COVID-19 pandemic, or just general government, looking at demographics and population trends, or architectural design, Utilities, understanding where the gas lines are, the electric lines, the internet lines. Those are all extremely important, and GIS can help answer those questions or help manage all that data at once. And so here's just a variety of different examples. One I didn't mention was crime. Understand where locations of crime are occurring within a community, and police and authorities are able to pinpoint those locations to understand, okay, we need more patrol in that particular location. And so with that, if you have any questions at all, please feel free to reach out to me at that email address that's listed there, or you can visit www.umflint.edu/GIS to understand the GIS Center, what we've done, our projects. And then you can also go to go.umflint.edu/GIS to understand what the university has to offer in terms of coursework. We do offer a GIS certificate program, and all that information can be found there. Thank you for tuning in, and have a great day.